All right, the first problem's on these complex numbers. We are supposed to add. And so if I want to add these, I don't need to worry about distributing anything for the parentheses. So I'm really just adding the two real parts and adding the two imaginary parts. And then combining them like they're like terms. So 4 plus 3 is 7. Negative 5 plus 6i would give me plus I. In number 2, however, I need to be a little more careful. The negative that's in between here needs to get distributed. So this really becomes 4 minus 5i minus 3 minus 6i. Then we can combine the real parts. So 4 minus 3 would be 1. And negative 5i minus 6i would give us a total of negative 11i. In number 3, we're multiplying, so we have to do either FOILing or double distributing, however you think of it, but I need to do 4 times 3 and 4 times 6i, so that would be 12 plus 24i. Then I need to take the negative 5 times 3, or negative 5i times 3, and negative 5i times 6i. So now I've got a couple of things. I've got some like terms I can combine. And 24i minus 15i would give us a positive 9i. But then that minus 30i squared, I squared we can replace with negative 1. So then I'm still not quite done, because this minus 30 times negative 1 is going to end up becoming a plus 30. And then I can combine those numbers again. So 42 minus 9i would be, or 42 plus 9i would be my final answer. For division problems, we're actually going to multiply. What we need to do is multiply by what's called the complex conjugate of that denominator, which really means we take the denominator but switch the sign that's in between them. And I'm going to multiply by that, in the numerator and in the denominator. So I'm not really changing anything. I'm multiplying by 1, but I'm multiplying by a helpful one. So on the top we just multiply basically like we just did. 4 times 3 and 4 times negative 6i. And then negative 5 times 3, negative 5i times 3. And negative 5i times negative 6i would give us plus 30i squared. But the reason we do this is in the denominator, when we multiply, I still do my double distributing. 3 times 3 gives me 9. But when I do 3 times negative 6i, that's going to get canceled when I multiply positive 6i times 3. And so then the only other piece I'm going to have in my denominator is 6i times negative 6i, which is negative 36i squared. So the top we can clean up a little bit. 12 minus 39i plus 30i squared. And actually, instead of that I squared, I'm going to write in my negative 1. In the denominator, I've got 9 minus 36, but I'm going to replace that I squared with a negative 1. So in the numerator, we end up with 12 minus 30. So 12 minus 30 gives us negative 18i. Sorry, negative 18. 12 minus 30 would be negative 18. And then we have the minus 39i that was already there. Then in the denominator, this 9 minus 36 times negative 1 really becomes 9 plus 36. And so we end up with negative 18 minus 39i all over 45. All right, number 5, we are looking for the vertex of this quadratic function. And when it's in this form, I really just have to look at what's inside here. And if I see x plus 4, that means the x coordinate of my vertex will be negative 4. And the y coordinate is exactly what I see outside. So the vertex of this one would be negative 4, negative 9. For the x-intercepts, I need to take a look and I need to figure out where x plus, need to figure out where this equals 0. So I'm solving this. I need to add 9 to both sides. That leaves me x plus 4 squared equals 9. Then I need to take the square root of both sides, but this is where I need to be careful. If I'm solving and I want to take the square root of both sides, I actually need to set up 2 equations. I need to set up one for the positive answer from this square root, and I also need to set up one for the negative answer from that square root, and that's where my 2 intercepts will come from. So solving the same step, we have to subtract 4 from both sides, but on this one of my intercepts is negative 1. The other intercept ends up being negative 7. For the y-intercept is where we hit the x-axis, where we hit the y-axis, and to find that we really just need to find where the function is 0. And I just need to plug that into my equation. So 0 plus 4 squared minus 9. Well, 0 plus 4 would be 4 squared minus 9, which is really 16 minus 9. So my y-intercept would be 7. And now I'm set to graph, because I know my vertex is negative 4, negative 9. So down here, I know my x-intercepts are at negative 1 and negative 7. And my y-intercept is way up here at 7. And for some problems, you might not be able to graph the y-intercept because it's off the chart. It's too big or too high or too low. That's okay. So something like that, and like that. And then once I have this graphed, I can find the domain and range. Well, the domain for all parabolas or all quadratics is negative infinity to infinity. The range, though, I do have a lowest point. This graph goes all the way down to negative 9, and it actually touches negative 9, but then it's not limited on the high end, so it goes all the way to infinity. Okay, next we have one on the other form. So here's one that's in standard form. To find the vertex, we have to do a little more work. So for the vertex, I need to look at, the x-coordinate of the vertex I can find by calculating negative b over 2a. And in this case, that would be negative 8 over 2 times 2. Well, 2 times 2 is 4, so this is really negative 8 over 4. So the x-coordinate of my vertex is negative 2. To find the y-coordinate, I need to plug it in. And if I end up crunching that out to get the y-coordinate, it ends up being 2 times 4, because the negative 2 squared would be a positive 4, minus 16 plus 5. So that ends up being 8 minus 16, which is negative 8. Negative 8 plus 5 would give me negative 3. So my vertex is the point negative 2, negative 3. For the x-intercepts, we need to handle this a little bit differently. If we could factor this, that would be an option. This one, however, does not factor. So then my other option is to calculate the quadratic, or use the quadratic formula. So I need to look at x equals the opposite of b plus or minus the square root of b squared minus 4 times 2 times 5, 4ac, all over 2 times a, which is 2 times 2 here. And then my advice when you're calculating this out is to calculate the stuff under the square root. It's called the discriminant. So you have a simpler number to work with there. In this case, if you do 8 squared, that'd be 64 minus 4 times 2 times 5. That would give you, 24. So then to get your two actual, and there are ways you can simplify this radical. For the quiz, you don't need to, but you need to be able to give both exact answers. So this would be your exact answer. One of your intercepts would be -8 plus the square root of 24 all over 4. The other one would be -8 minus the square root of 24 over 4. But to actually graph them, we don't want, there's no way I could eyeball that and know where the graph is. So it's fine to calculate it out to get your approximate decimal. So this would be -0.78. The other one would be -3.22. So those are going to be the intercepts that I'll plot. And I'll just eyeball them as close as I can. But you also need the exact version, or an exact version. If you simplify it further, that's okay. So let's zoom out here and let's get our information. Oh, we need the y-intercept still. Y-intercept, just like last time, I'm just going to plug in 2. So f of 0 is my y-intercept. And in this case, it's a little more straightforward because that's 0, that's 0. My y-intercept is just 5. So now let's plot. I've got a vertex at -2 and -3. I've got one intercept at -0.8, so a little less than -1, or a little to the right of -1. The other one's a little past -3. That's good enough. My y-intercept is at 5, and now I can sketch. So if you have to use the quadratic formula and you don't get exact answers, that's okay. You can just sketch them the best you can. My domain is -infinity to infinity. And then my range, this one also opens up. So it has a low point at -3 for the y value, but then goes forever after that. All right, in this one, what is the vertex? The vertex is 3, 6. As far as what are the x-intercepts, we're going to do the same process we did before. So we're going to take this. Actually, let me zoom in a little bit. And solve it. So I need to subtract 6. That gives me -2. Okay, and I still can't quite square root because I have that negative over here, or that -2 over here. So I need to divide, and now I'll be able to take my square root. However, this time when I take the square root, I don't end up with a nice neat whole number. Square root of 3 is like 1.73 blah blah blah, and I need to give an exact answer first. So to start with, I'll have x minus 3 equals the positive square root of 3, and x minus 3 equals the negative square root of 3. To give the exact answer, it would be square root of 3 plus 3. That's my exact answer. For the other one, I would add 3, so my exact answer would be x equals the negative square root of 3 plus 3. But then to graph it, we're going to also want an approximate. So you can punch that into your calculator. In this case, if you type that in, square root of 3 plus 3 is right around 4.73, and that's the one we'll graph. And this negative square root of 3 plus 3 is right around 1.27. So we need the exact answers for this question for what are the x-intercepts, but we can use the decimals when we're graphing. And then for the y-intercept, we'll plug in 0. So f of 0 for this one would be so that gives us negative 2 times, if you take negative 3 and square it, you'd get 9. So it'd be negative 2 times 9 plus 6, which is negative 18 plus 6, which means our y-intercept is negative 12. So let us graph. My vertex is at 3, 6 this time. My x-intercepts are a little bigger than 1 and a little bigger than, or almost to 5, a little less than 5. My y-intercept is way down at negative 12, so that would be off this graph. So I'll sketch it in. And then this time our domain is again negative infinity to infinity, but our range goes all the way down to negative infinity, but this one has a maximum. This one goes up to 6 at its highest point. Here. Oops. Okay, and then the last parabola we'll look at, we have another one where to find the vertex, we're going to have to do a little bit of work. The x-coordinate of the vertex is at negative b over 2a, which here would be the opposite of negative b, or if you have negative 6, would be positive 6 over 2 times 1 in this case. So it's really just 6 divided by 2, which is 3. To get the y-coordinate, I just have to plug it in. So I'm taking 3 squared minus 6 times 3 plus 5, which is 9 minus 18 plus 5, which would be negative 4. So then my vertex is the point 3, negative 4. For the x-intercepts, you certainly can do the quadratic formula. It will absolutely work. This one does factor, and if we can factor it, that goes a little bit faster, and there's a little bit less likelihood that we make a mistake. I want to know where this is 0, but this one factors into x minus 5, x minus 1, which means I have x-intercepts of 5 and 1. And then to get the y-intercept, just like we have a couple other times, we'll find f of 0. And 0 squared minus 6 times 0, all that's 0, so it ends up just being 5. And then if we go graph, my vertex is at 3, negative 4. And my x-intercept is at 1 and at 5. My y-intercept, this one's on the graph, it's up at 5, and then I can sketch. And then what are the domain and range? Domain, one last time for a negative infinity to infinity. The range is from negative 4 to infinity. Whoops, and then I wrote that wrong. When we're doing range, my graph actually touches negative 4, so I should have a bracket there.